Hey everybody, this is Mr. Ainsworth, and we're going to get into the chapters 1 through 8 cumulative review. That means that it covers chapters 1 through 8. Okay, so let's get right to it and let's start reviewing problem number 1. All right, by the way, this is multiple choice. Even so, I want you to show setup, process, and all side work. Okay, do that. So get out a piece of paper if you haven't done so. Also, get out your TI-84 graphing calculator or scientific calculator of your choice and get those two things ready to go and let's go for it. Okay, here we go. First thing we got to do is understand what technique do we want to use. Well, let me see. We know an angle, we know one side, and we're trying to find the opposite side of the angle, and that calls for a little trick. So right away, I know that from angle to side is called the opposite side. Longest side opposite of the right angle, well, guess what? That is called the hypotenuse. All right, so HYP. So, Katoa. Everybody say SOHCAHTOA. All right, sine is opposite divided by hypotenuse, cosine adjacent divided by hypotenuse, and tangent opposite divided by adjacent. And that means that this calls for the sine function, all right? We know that the sine of the angle is equal to the opposite side divided by the hypotenuse, 10.6. All right, that's called my setup, okay? Now, number 2, I want to show some process, okay? So get out your red pen and multiply both sides by 10.6. Multiply both sides by 10.6 there. Simplify. All right, and my exact answer is 10.6 times the sine of 70 degrees. That is equal to x right there. But the answer or the direction says, hey, you need to get your answer to the nearest tenth. That means you got to round your answer, right? So read the directions. Use your calculator when appropriate. Now it's appropriate. All right, so here we go. So you go 10.6 times the sine of 70 degrees, right? With the TI 84, it's pretty much brainless because all you do is enter in exactly how you see it. As long as you enter in correctly, you're good to go. So you got to check this right here. Check your expression, make sure you wrote it down correctly, which I did, and then you could round your answer to 9 point, well, it says 9.96, but it says to the nearest tenth, right? So look at the second digit and round the first. So it's basically 10. So that is approximately equal to x here, again, to the nearest tenth. All right, so A is my answer. So once again, I do my side work on the side. This is problem number 1 right here. Put that right there, number 2. All right, number 2. Find the magnitude or length, underline that word and say length, and the direction of the vector. So two different things. First of all, never eat shredded wheat, okay? North, east, south, west. So the question is, how many degrees east of north or south of east, is this vector going? And let me highlight the vector. The vector is this arrow right here. All right, and you have a right triangle in here. So we need to figure out our angle to figure out the direction. All right, angle. And we also need to figure out the length. And that we can use the Pythagorean theorem. So let's find the length first. We'll call that L. Magnitude, length, we'll call that L here. L. Right there. There we go. So length, we'll call that L. So use the Pythagorean theorem. So 50 squared plus 150 squared is equal to L squared. Pythagorean theorem. Okay, so you get 2,500 here plus 225 with two zeros. 22,500 is equal to L squared. If you don't believe me, okay, let's do it. Okay, so we got 50 squared, boom, that's 2,500 plus 150. No, I won't do it like that. 150 squared. Okay, right there. That's 22,500. Now you got to add 2,500, right? So let's do that. That's 25,000. So this is 25,000 is equal to L squared. You got to square root both sides. And you get L is equal to the square root of 25,000. Now, it says, look at the decimals here. Look at that. It's rounded to the nearest tenth. So if you look at your answer choice, we got to square root this bad boy. So take this square root. Okay, so second x squared, you see the root symbol right above it. Enter in our number. Okay, 25,000. And you get about 158.1. So 158.1 is equal to the length, or the magnitude. Now the direction. Okay, what is that? Well, that calls for finding the angle. Now, let me see, 158.1. Both of these are possible. These are not. So let me see. So neither one. Just looking at the answers here, that's not possible. That's not possible. So one of these is. Now west of south. That means it's going over here. Okay, west of south is in this direction, which the vector's not going. So it can't be this one, because this part doesn't make any sense. So the answer is H. But let me show you how to get it. Let's talk about that. Let's use the tangent function. Let's find the angle. Let's find x here. So let me use the margin here. So find the angle. So the tangent of the angle is equal to the opposite side, 150 divided by 50. So 150 divided by 50. So that just simplifies tangent x equals 3. And whenever you find the angle, you got to use the inverse. So the angle is equal to the inverse tangent of 3. What's that? Well, again, that's a calculator problem, right? So let's work it out. Let's clear out the calculator. Go second tangent, which is the inverse, right? Inverse tangent of 3 is about 71.56. So this angle right through here, right there, is 71.5 degrees. All right, south of east. That rounds to, look at this, 72 degrees, right? So this makes sense. So it's this answer right here is H. So it's the same magnitude or length, and it's the same direction. There we go. So that's a little bit of chapter 8 right there, a little bit of trig, right? Both of these questions right here, chapter 8 questions, trig. Okay, number 3. Write a postulator theorem that, by which postulator theorem are the triangles congruent? Well, let me see. Angle, angle, then a side. Angle, angle, then a side. So this is an angle, that's an angle, and that's a side. Looks like this, right? So pick the right one. You know, we have two angles in the non-included side congruent to two angles in a non-included side. Angle, angle, side. Just look at the order. Number 4, what's the exact length of x? Exact length. This is a 30, 60, 90 triangle, so no trig, right? No trig, no calc. Okay, that means exact answer. That's what that means. All right, so to go from here to here, you divide by 2, so this is 5. To go from here to here, you multiply by rad 3, so this is 5 rad 3. So that's not it, that's not it, that's not it. G is it. So to go hypotenuse to short, you divide by 2, right? 10 divided by 2 is 5. Boom, right there. Multiply by rad 3 to get to the medium length side, and you're done. That right there is another chapter 8 question right there. Chapter 8, section, this is H2, special rights. Okay, next one. Okay, the triangles are similar. Find ON and TQ. All right, so ON and TQ. Okay, so let's try to work this out here. So let's understand here, first of all, that RT and is, or the ratio of 4 to 5, let's say, 4 to 5, is equal to or proportional to 3 to ON. So 3 to ON. So cross multiply. So 4 times ON is equal to 15. Divided by 4. Divided by 4. So ON is equal to 3. And see, 3 times 4 is 12. Remainder 3. So 3/4. Or 3.75. So I got ON here. 3.75. Right? Bigger triangle, longer sides. Right? So 3.75. So it can't be that. Can't be that. Now let's find the other triangle TQ. So let's use the same ratio here, 4 to 5. But let's go TQ to this side right here to 4, right? Equals TQ to 4. left to right, left to right. So here we go. Cross multiply, so 5tq is equal to 16 divided by 5. So tq is equal to 3 1/5, or 3.2. Just look at your calculator. 1 divided by 5 equals, boom, 0.2. So 3 point, excuse me. I said it right, but I didn't do it right. I didn't write it right. This is 3.2. Okay, so TQ is 3.2. So that's not it. And this is it right here. So work it out and then select the right ones. Cross out the ones that don't make any sense. The hypotenuse of the isosceles right triangle is 6 feet long. So you have an isosceles right triangle, which is a 45, 45, 90, and the hypotenuse, look at this, is 6. Boom. So isosceles right means that it's a 45, 45, 90. What is the length of the leg? Well, to do that, you got to divide by rad 2, right? So 6 divided by rad 2, you got to rationalize. What do you get? You get 6 rad 2 divided by rad 4. That's 6 rad 2 divided by 2, and that's 3 rad 2. Why? Well, because usually 6 divided by 2 is 3. So 3 becomes 3 rad 2. All right. Next one, number 7. Going back in time, the triangle has measures these, this, and this. Okay, so you got 3 angles. What are the measure of the angles from smallest to largest? Notice the directions, right? Well, the sum of all 3 angles is 180. You guys know that. So what does that mean? It means 2x plus 8 plus 3x plus 5. You don't need the parentheses, but I'm going to put them in just so I can emphasize something here. Plus the third angle is equal to 180. Now algebra skills come in. Add like terms. So 2 and 3 is 5 plus 6 is 11. So I have 11x here plus 8 plus 5 and a plus 2. So that's 10 and 5, 15. So plus 15 is equal to 180. It's all algebra from here on out. All right, so 11x is equal to 165. Divide by 11, divide by 11. If you don't know what it is, if you don't know it's 15, then well, then do it on a calculator, right? Or do it on the side. I don't care how you do it. Just go for it, man. All right, it's 15. So x is 15. So then find the angles, right? And then you got to substitute them in. So the angles, what are they? So here we got 2x plus 8. Becomes 2 times 15 plus 8. 30 plus 8. First angle is 38 degrees. Second one, 3x plus 5. 3 times 15 plus 5. It's 45 plus 5. Next angle, 50 degrees. So 38, 50, and something else. 38, it can't be that one because that's a 52. This one doesn't have a 50. This can't be that. Can't be this one. So it's got to be the one in the middle, C, right? So let's figure out the last one. Just to verify, 6x plus 2. Okay, it's 6 times 15 plus 2. That's 90 plus 2, or 92. There it is, right there, it's C. So my angles are here, here, and, well, 92. I got to write it down, right, I guess. So there's my third one right there, 92. And there they are. There's your answer right there. Okay, what's the greatest? Well, I don't know. Let's figure these out, and then we'll figure out the greatest is, right? So sine of A is 4/8. So 4/8 is equal to 1/2. Tangent of A is 4/6. So 4/6 is 2/3. That's bigger than a half. Cosine of C is 4/8. 1/2. Tangent of C, and that's equal to 6/4. 6/4 here, and that's equal to 1.5. So the answer's got to be J, tangent of C. Okay, now what's the biggest? The greatest. Focusing on your directions here, that's what you're looking for. The greatest is right here, so it's got to be the tangent of C. So in a multiple choice test, sometimes you can eliminate the ones that aren't that don't make any sense, and sometimes you got to work them all out. It all depends on the problem. All right, let's keep working here. Okay, right triangle has a leg that is 5 inches long. So right triangle, got a dry one here. Right triangle, it has a leg 5 inches long. Hypotenuse is 13. Final length of the third side. Okay, Pythagorean theorem, 5x plus x squared is equal to hypotenuse squared. The leg squared plus leg squared is equal to hypotenuse squared. That's your Pythagorean theorem. All right, leg here, hypotenuse opposite of right angle is 13. So 25 plus x squared is equal to 169. Subtract 25 and get x squared is equal to 144. That means x is 12. Y 12 squared is 144, right? So there we go. Next problem, number 10. 15-foot ladder slides down a wall until the ladder forms a 52-degree angle with the ground. Okay, so let me see. This is number 9. Number 10. Here's number 10. Number 10. So you got ground. Okay, and then building. Okay, ladder. Okay, you see the right triangle? Now there's the ladder right. Now, it says a 15-foot ladder. So you label it 15 feet. It makes an angle 52 degrees with the ground, not the building. So it's down here as opposed to up here. This angle up top would be the angle between the ladder and the building. But it says with the ground, angle with the ground right here. So I got to put it down here between the ladder and the ground. How high up on the wall is the ladder? So what's this? What is this distance right here, x? I don't know. Let's figure it out. So opposite of that is x and ladder is hypotenuse, right? So ka toa. All right, opposite divided by hypotenuse is the sine function. So the sine of 52 degrees is equal to x divided by 15 multiplied by 15, and you're looking at your exact answer there. So, but we wanted to the nearest tenth, so let's figure that out. Let's take 15 times the sine of 52, and you get about 11. What was that? 11.82. So 11.82. And that's got to be this one here, feet. Okay, number 11. Stone pathway forms a diagonal with a square garden. Ooh, there you go. Square pathway forms a diagonal of the square garden. One side of the garden is 40 feet. It's a pathway. All right, so you got a square garden. All of them are the same, right? Here's the diagonal. There's a right angle. Now it's a square, so this has got to be 45. And let me see, one side of the garden is 40 feet long. How long is the pathway? So let's call this x here. So on that right here, there's no work to be done. To go from leg to hypotenuse, you multiply by rad 2. That's all you do. So x is equal to 40 rad 2, and you're done. And it has to be b right here. Okay, number 13. Okay, which quad, which is a four-sided figure, has congruent diagonals? Congruent. That means equal. Okay, trapezoid. Here's a trapezoid for you. Okay, there's a trapezoid. Okay, let me draw another trapezoid. Trapezoid has one pair of parallel sides. Now look at this diagonal in blue compared to the diagonal in red. Okay, obviously the red's longer than the blue, so it can't be a trapezoid because it obviously doesn't have congruent diagonals. Even if you draw a parallelogram, here's one right here. Parallelograms right there. Here's one diagonal in red, and here's another one in blue. And clearly the blue's longer than the red, so it can't be the parallelogram. Rhombus. Let me show you a rhombus. Right here. Here's a rhombus right there. Here's one diagonal in red, and here's another one in blue. Clearly can't be the rhombus either. It's got to be the rectangle. And if you draw a rectangle, it kind of makes sense. Here it is right here. Okay? The diagonals are clearly the same. So one here and one here. We actually prove that together. So here's one diagonal, here's the other one, and they're the same. So this one has congruent diagonals, the rectangle. Okay, next problem. I noticed that I have a right angle here, and that's 90 degrees. So from here to here is 90 degrees. So the sum of the two adds up to 90. And this is number 14 here. So we have x plus 30 plus 4x plus 10. They sum up to 90 because they add up to a right angle. All right, let's kick in a little bit of algebra. Let's add up the like terms. We got 5x here plus 40 here, and that's equal to 90. That means 5x is equal to 50, and that means x is equal to 10 because 5 times 10 is 50. So x equals 10 right here. Okay, and then the rest here. Let me see. Write a counterexample. Counterexample is an example that shows something false. All right, you need to. It's an example to show it is false. That's what a counterexample is. So let's find one. If you are in a tree, then you use the ladder. Oh, that's not true. If you're in a tree, then you could have just climbed it. Okay, so this here has many different examples. You could have just climbed the tree with the branches. So climbed the tree. Because you don't need a ladder always, do you? A lot of kids climb the trees. So just because you're in a tree doesn't mean you use a ladder. You could have just climbed the tree. So that is a counterexample because that's a false statement. All right. And then let me see. We're not going to worry about the rest, okay? Okay, so we can skip these for right now. Concentrate on the basics. There you go. Those are the solutions up to 15. All right, remember it's a video, so if you need to go check out anything, you could always rewind it and listen to it again. All right, I'll see you in my next lesson. Mr. Ainsworth signing off. See you then.